Okay, now you can do these with this kind of a calculation with a lot of other numbers. Carl Sagan had estimated that instead of being 2 in 10 million, 2/10 millionths, he had calculated there would be hundreds of thousands or even a million civilizations. That's what they did at the Burkina conference. Now you think, well, how did you get those kind of numbers? Well, what they thought was this and this would be about the same. But then they thought, like what Reese had said, 1 in 10,000 stars would have it that have planets would have an Earth. They thought everything would have an Earth. Okay, well we've learned that's not true. That was back in the 70s. We now know that that's not true. There's not one. Every star doesn't have an Earth. We know that. Okay. The rest of this stuff about life, they thought all would get life, so they would agree with Reese. But technologically advanced, they figured that, well, if you got life, you get technologically advanced. They figured everybody would get technologically advanced civilizations. And then it would just boil down to how long does a civilization last? And depending on how long the civilization lasts, you get more or less civilizations in the galaxy. But this is what the Drake equation is. Obviously it is it's a guessing game. And like, what do you think is reasonable, and what does that mean for your final answer? So this is the Drake equation in action. I'm not writing out like a formula for it, but this is exactly how it's done. If you're interested in messing with these numbers on the supplemental material on the class webpage, I have a little spreadsheet. You can go type your own numbers in and see what you come up with for number of civilizations in our galaxy. Obviously, under this one, we came up with nothing, okay? Because 2 over 10 million, that rounds up to down to 0 in our galaxy. Sagan's idea that there would be millions, that's where Star Wars, Star Trek, Marvel Universe, all that comes from. But that can't be right, okay? We know that is not going to hold up, because if there were that many civilizations out there, we would have detected them already. This runs into a question a couple of people asked, which is, how do you know, like when there was an article that was cited that said there's no type 2 civilizations in our galaxy, no type 3. And so how do we know that? Well, the answer is we would have seen them. Okay, these would be really powerful civilizations that affect the environment around them in a significant way. A type 3 civilization would affect its entire galaxy. And so people have done surveys looking at galaxies to see, surveying large numbers of galaxies to see if any of them show anomalies, like, too many stars, too few stars, too much radiation of one sort or another that could be explained by some artificial phenomenon acting on a galactic or close to galactic level. And haven't found anything. There's been surveys of stars within our own galaxy looking for the effect of, for example, surrounding a star with some sort of energy catching device, like a Dyson sphere, that would produce certain effects. They're not being found. People with the Kepler satellite, when they're watching to see planets passing in front of stars, it occurred to people that, well, if you had aliens that had built what are called megastructures, large orbiting objects, or even, say, a giant fleet of star destroyers or something in orbit around their sun, that swarm of spaceships or big structure passing in front of the star would produce an effect that we could detect. So people have actually looked at the stuff that we're studying to see, are there any signs of artificial structures, orbiting these things? And the answer is no. Okay, we're looking, and the universal thing that we're finding from SETI is we're not finding it. Okay, which brings us to this question that quite a few people asked, which is, why are people still doing this? There's a lot of people asked questions about that. Will we ever stop looking for aliens? How long is this SETI stuff going to go on? Someone asked, is it legal? It's legal. If you want to go build yourself an antenna and listen for aliens, you can do that, right? It's a free country. You just have to have your own money. How long are people going to keep it up? And the answer to that is, as long as there's people with money who find it interesting, they'll probably keep doing it. But there's no doubt that it is becoming a harder and harder sell to say, yeah, we're gonna find aliens. That's time is passing. We keep hunting, and everything that we hunt doesn't turn anything up. So that is you know, that makes the idea certainly more of a challenge to convince people that it is worth doing. Somebody said, you know, like, how long should people be allowed to waste time like this? And you know, again, it's their time, and if they've got the money for it, then you know they can do it. You know, there's plenty of other stuff that people do that it's a waste of time. So. Now, so that's two of the big questions people asked. The other big question people asked was this one: spontaneous generation. Like, where do people come from? How did people become people, for example? What causes life to spawn? And the answer to that question is we don't know. Okay. Now, Aristotle thought that matter had a natural life force, that you just had mud and you added some water, and you know, water is already mud. Mud has water. Mud and some sunlight, and the earth itself just wanted to make life. And so you could just get life popping up out of the mud. A student mentioned reading about how people thought frogs grew out of the mud, because wherever you saw mud, there were frogs. And people thought that. There's an ancient poem about seeing frogs, you know, where part of them is formed and the other part is still mud. They thought they just popped out of the mud. That idea has not worked, okay? That idea has not panned out. And but as I said in the book, even as late as the late 1800s, Carl Nageli was saying that life originated from the earth, and then it would like evolve upward into more advanced creatures. No, okay. As far as we can tell, no life spontaneously appears out of material. A student asked, if that's the case, how did you get life in the first place? And that's a really difficult question. So you always will hear, scientists still hold on to the idea that somehow life appeared out of inanimate material, but we have no idea, right? Even if you take this from a religious perspective, I know there's there's some students in the class who often in their questions will reference the Bible to me. You know, like, well, the Bible says that God made man, you know, made humans out of the dirt. So even that is spontaneous generation under the action of God. So in other words, you have to have, like, how did you get life in the first place? And this is why Aristotle's ideas are so appealing, because you don't have to answer these kind of questions, right? Aristotle just said everything has always existed, it's always been, and it always will be, and you don't worry about it, okay? But we've got the Big Bang Theory. We don't believe in Aristotle anymore. And so we're stuck with the basic idea that we don't know where life came from. This has a huge impact on the idea of space aliens, though, because when people like Thomas Dick and stuff like that, back in the earlier chapters on aliens that we were talking about, well, they were estimating, oh, there's life everywhere. There's life everywhere. Why would they do that? In part because they believed in spontaneous generation. They believed that matter would just naturally hatch life out. So of course you're going to have life everywhere. We don't believe that. Okay, we don't believe matter naturally hatches life out. We've never seen that happen. Okay, everything that we see that's living comes from a mother and a father, except for like bacteria that split. They have budding, right? So they just have, you know, a parent. So if we don't know where life comes from, that's a huge issue in like a Drake equation calculation, because we know, for example, that you can't just get life automatically. There's no spontaneous generation. So how do you get it, right? We know it has to be a rare occurrence, because if it wasn't rare, we'd see it happen, right? We'd see frogs emerging, you know, mud turning into frogs. We don't. We don't see that. Okay. People have tried to make life, okay, and even with people trying to make life, they've not been successful. So, you know, and of course, even if we were able to make life somehow, that wouldn't be the same as life coming about on its own. So we have no idea where life comes from. So it is possible in the Drake equation that life itself is a 1 in a trillion, quadrillion, blah, blah, blah. It might just never happen, right? It leaves open the idea of a very uninhabited universe, a very empty universe. So that is all about what people have asked about the spontaneous generation question. I'm going to pause it for a minute, make sure I'm not missing anything. Okay, a few other questions that people asked. How did Kardashev get his system of type 1, type 2, type 3? There was this guy, this is back in the 60s. People were talking about the idea, Cocconi and Morrison had published their paper about how we think, you could possibly detect life on planets orbiting other stars through radio. And I think Kardashev, began thinking about like, well, what kind of things could be out there that we would detect, and it came to his mind that you could have some really wildly advanced civilizations out there that, we tend to sort of think of things like our level and then maybe a little bit more advanced. But Kardashev realized, the universe is old and there's no reason that there couldn't be a civilization that's, 100,000 years ahead of us or even more. Okay. And so that's where he came up like how high could a civilization go? And then he thought of like, well, there's us, and then how much energy could we possibly get from our own planet? And that's a type 1, it uses the energy of its own planet. And a type 2 is the energy of its star, and a type 3 is the energy of its galaxy that it uses. Someone asked, would we qualify as a type 2 because we have solar panels? And that answer is no, because the solar panels are on our planet. So we're still talking about planetary energy, the energy from the sun that hits our planet. The way you would have to move toward a type 2 would be to orbit the sun with solar panels so that the amount of area of the Earth is greatly multiplied, so that we know instead of just using our planet to catch the sun's energy, we have this huge array of solar panels surrounding the sun to catch like a large chunk of the sun's energy. And those kind of things should not be hard to see through a telescope. Okay, the effects of them should be pretty obvious, and so that's why people have tried to do things like look for type 2 civilizations, because if you've got a big array of panels around your star, that's going to make the light from your star look weird. Okay, as they orbit around the star. So that's why we look for these sorts of things, and of course we've not been successful in finding them. A couple of people asked about Kepler, the Kepler planet. Kepler 452b. Okay. What about it? That is a planet that seems to be a Earth-sized planet orbiting a sun-like star. But somebody said, was talking about, this is just like Earth. We don't know that. Okay, we believe that it is Earth-sized. Okay, and it is orbiting a sun-like star. These are true, but we don't know what it's made out of. We don't know anything about the planet. And in the right zone. Okay, so but we do not know that makes it an Earth-like planet. For example, Mars and Venus are both Earth-sized planets, roughly, orbiting in the roughly habitable zone of the star. And Mars and Venus both suck as a place to live. So this planet could be a Venus as well as it could be an Earth. We just don't know, because how many things have to be just right in order to be Earth-like? Can you be Earth-like by just having some of the stuff Earth has, or do you have to have every little thing? And the more every little thing that you have, the less likely it is that you're going to find an Earth-like planet. Where is the Kepler? It's about 1,400 light years away, which means that to get there at the speed of our current technology would take millions and millions of years to get there. That's why we can only see them through telescopes. And even if you could travel at the speed of light, it would take 1,400 years to get there. So it's not anywhere close. it's not a close by place. Stop this momentarily.